Everybody thinks China is trying to catch up in advanced chips. 2nm EUV beating TSMC. After spending time at SEMICON China last week, I realized something very different. China is not trying to win the same race. It's building a scale at the level we have not seen before. And once you see the numbers, the factories, and the strategy behind it, you understand this is not about catching up. It's about changing the game. I just got back from SEMICON China 2026 in Shanghai, which took place from March 25th to 27th. And what I want to share in this video is not just impressions from the show floor, but what the data, the presentations, and the conversations reveal about the China's semiconductor strategy. Because when you combine what is being said publicly and what is actually being built on the ground, you start to see very clear the direction. And honestly, it's quite different from what many people in the West assume. One of the most striking insights from the conference was the scale of planned expansion. Globally, semiconductor manufacturing capacity is expected to grow from around 25 million wafers per month today to roughly 44.5 million by 2030. That alone is impressive. But the real story is China. China's capacity is expected to grow from approximately 4.9 million wafers per month to 14.1 million over the same period. That means its global share increases about 20% to more than 30%. And what really matters here is not just the percentage, it's the absolute scale. We are talking about adding the equivalent of entire semiconductor industries. And this expansion is backed by concrete projects. Right now, it is estimated that China has plans for around 49 new factories by 2030. 49! To put that into the perspective, it's not incremental growth. This is industrial acceleration, and what you feel on the ground is that this is already in motion. What becomes clear very quickly at SEMICON China is that this is not about one company or one breakthrough. It's a full ecosystem strategy. China is expanding simultaneously across logic, memory, power semiconductors, packaging, materials, and equipment. Companies like SMIC and Huahong are scaling foundry capacity. YMTC and CXMT are pushing forward in memory, NAND, and DRAM. And at the same time, equipment players like Naura and Atomic are growing fast. What makes this different is coordinations. In many regions, semiconductor growth is fragmented. Here, it feels aligned. The goal is not to lead in one segment. The goal is to be strong enough in all segments, because that creates resilience. Another major insight is the importance of mature nodes. In many discussions, the focus is always on the most advanced technologies, 3nm, 2nm, and that's not where the majority of chips are produced. At SEMICON China, there was a clear emphasis on the nodes like 28nm, 40nm, 65nm. This is not the cutting-edge nodes, but they're critical. They power automotive systems, industrial electronics, power infrastructure, and large parts of the global manufacturing. And China is aggressively expanding in exactly this space. Because controlling mature nodes means controlling supply chains. It means becoming indispensable to the global industry. And this is a very different kind of power that leading at the bleeding edge. Another strong theme across the conference was the shift from the pure scaling. Instead of just making transistors smaller, the industry is focusing on a system-level innovation. This includes advanced packaging, chiplet architectures, heterogeneous integration, and power devices like SiC and GaN. What this means is that the performance gains are no longer coming only from the smaller nodes. They're coming from the smarter system design. This is a key insight, because even if country is behind in lithography, it can still compete and even lead at the system level. And China is investing heavily in exactly these areas. Another very important signal from SEMICON China is how central AI has become. There were multiple presentations showing how demand for computing power is growing exponentially, faster than traditional Moore's law. Some even referred to this as a new Moore's law, driven by AI workloads. And what this means is that the constraints are changing. It's no longer just about transistor density, it's about power consumption, memory bandwidth, system efficiency. And this shift plays directly into the strength of system-level innovation, which again aligns with where China is investing. Now we have to talk about lithography. China does not have access to EUV machines from ASML, and that is a real limitation. It makes it extremely difficult to compete at the most advanced nodes. And what's interesting is how the strategy adapts. Instead of focusing on catching up, China is exploring alternative paths: 3D integration, advanced packaging, multi-die systems. There are presentations showing the evolution towards the chips and hundreds of billions, even trillions of transistors, but not through the traditional scaling alone, through the system architecture. And this is important because it suggests that the future of performance may not depend only on lithography. Another major focus is equipment. China is actively working on reducing reliance on the foreign suppliers. There is already a push toward achieving around 50% domestic equipment usage in the new fabs. Companies like Naura and AMIC are making significant progress, but there are still gaps, especially in lithography. And everyone in the industry is aware of that. Still, the direction is clear, and this is a long-term effort to build independence. One topic that kept coming up in conversations is talent. Building fabs is capital investment, but operating them efficiently requires deep expertise. And that cannot be built overnight. China is investing heavily in education and training, but experience takes time. And this could become one of the key constraints on how fast the industry can scale. Now, if we zoom out, this is not just about technology. This is geopolitical. The US is trying to slow China's progress through export controls. China is responding by accelerating domestic capabilities. The objective is not necessarily to lead at the most advanced node. It is to reduce dependence, to ensure that the critical industries can continue to operate. And the target is clear. China aims for around 50–60% semiconductor self-sufficiency by 2030. This is a huge shift. So, what did I really take away from SEMICON China? China is not trying to replicate Silicon Valley. It is building a different model. A semiconductor ecosystem that is large, integrated, and increasingly self-reliant. It may not dominate at the most advanced nodes. It may dominate in a scale. And in a world where everything depends on chips, scale matters a lot. So the real question is, will the future of the semiconductors be decided by the smallest transistor or by who builds the strongest ecosystem? And more importantly, are we even measuring the right race anymore?